Hey everyone, and welcome to another Into the Terminal. Today we're going to be talking about troubleshooting problematic containers. Nate, you want to jump us into the terminal?
Sure thing. So we've been talking a whole lot about containers and how to network them and put them in pods and run applications and whatever. We haven't talked a whole lot about what happens when things go wrong, right? So we'll go into a little more depth on why this is, we think, an important topic. But we're just going to get right into a little demo here. So I've got a container running, just runs Apache. You may recognize this from previous demonstrations that we've had. It's just the same old HTTPD container we've been using. But if we try to access the website on port 8080, which you can see from up here, it is listening on 8080, forwarding it to port 80, we get a permission denied error, right? Now, obviously, this is a pretty simple thing to troubleshoot, but bear with me, right? Just run with it here. Permissions inside of a container are sometimes harder to troubleshoot than permissions on, Apache running on a host that you can just SSH into, because you don't have necessarily the visibility that you do when you're just SSH into a machine, right? So what we're going to do is I'm going to show you how to get a shell within your container, right? So you might picture a container like a virtual machine, even though it's not. It does have an environment and a shell running inside of it. But it's just this file system that's inside of contexts and inside of a namespace, right? So we're going to do this with a command called podman exec, which I just pasted in here. So we're podman exec IT, which tells it to run interactively with a terminal. The HTTPD container, that's the name of the container. You can see up here, that's the name I picked. And we're going to run bash, right? And here we are. Now we're right here at a bash prompt inside of our container, inside of the namespace for our container. Now, we all know we could, of course, go look and see where Apache is storing its web root, but I'm telling you right now, it's in the default location, which is in var www HTML. And if we do an ls-l, we'll see that the index file is owned by root and root, which is not that abnormal, but the permissions on it are set so that root can read, write, read, the group can read, but others cannot read or write or anything. There's no permission. Okay. Now, this is a mapped in volume, so we could fix the permissions either at the host level or inside of the container. But in this case, we're going to do it inside the container just because I think it's, a fun little demonstration. So we're going to use the same old command that you normally would in a normal bash shell. To group, we're going to change the group. Now, obviously, we can just make others readable. I've chosen to just change the group for the index HTML to Apache. And what this should do is now if we do another ls-l, you can see now that the group, or the ownership is root, the user is root, but the Apache group now owns the file. So now the group should be able to read it. Of course, Apache is the group that the HTTPD service runs within. So now it should work again. So we're going to exit out of the container just the same way you'd exit any other shell. And then we're going to try the same curl command again. And ta-da, our super businessy website is up and running. Now, one more thing I want to show you quick. This is the directory that I've got mapped in. And you can see here that the ownership reflected in the file system on the host, right? So as I said before, you can change the permissions at the host, right? So now that you've gone through and realized what the permissions problem was, if you were going to go to redeploy this thing later or, deploy it on a different host, you would simply know, fix these permissions on the host, and then they should work within the container. Yes, Mr. Scott, I see your hand is raised.
One thing about that, the reason that it shows that the Apache user is the owner of that, or the group rather, is because on the host we have the HTTPD RPM installed.
Right.
The HTTPD RPM was not there, you would see just a group ID number that had been applied from within the container. So, yeah, there's a little bit of weird
for numbers. Yeah.
Dealing with
the group.
Apache user is UID and GID 48, but Depending on what software you have on the container host, you might see some differential view when you look at it from outside versus inside.
Yep, that's a good point. And in that case, on the host, you can still change the ownership using the ID number. So as long as you know the ID number that the container expects, you can change it on the host using that ID number as well.
All right, so stay with us after the transition where we go through some more troubleshooting stuff. Nate, give us a taste of some of the techniques we're going to talk about.
Sure. So we're going to poke around at some more executions like that. We're going to do some namespace stuff to play around with running applications from the host inside of the container. And we're going to look at logs. So yeah, stick with us.
Great, and don't forget to mash that like button. And if you want to get notifications when we are running these, click subscribe. And if you think you know somebody that would benefit from having a look at the critical path or the content after the transition, go ahead and share it with them. See you on the other side. So Nate, troubleshooting containers.
Yeah. So I don't know about you, Scott, but when I started tinkering with containers, troubleshooting was actually one of the hardest things for me to wrap my brain around because all of a sudden everything's different. When I went from physical machines to VMs, it really wasn't that difficult because a VM is just another machine. It's just you don't have physical layer to tinker with. You have to learn that part. But a container is like a whole new methodology. My dogs are about to go crazy. I'm very sorry if the dog starts. Yep, there we go. Hang on.
So one thing that we should also probably think about is, in the container world, it's rip and replace, right? You have a problem, you kill it off, you spawn up a new one to replace
Yep.
it. So Nate, when would someone want to troubleshoot a running container image versus
So
just killing it off and starting it up again?
So at a point where you're trying to figure out what the issue is, maybe simply rebuilding and redeploying the container isn't going to fix it, right? Now you could try that first, obviously, and if that fixes it, great. But if it doesn't, sometimes you got to get a little more hands-on and just try to poke around and figure out what the problem is. Or if you're in the process of writing an application, right, and you're trying to containerize that application, you may not know exactly how it's going to work inside of a container yet, and you're still trying to figure that out, or you're learning, right? There's lots of reasons.
Right on. So I see on our next topic, we're going to talk about looking at logs. Logs are one
Hmm.
of the things we talked about in our troubleshooting arc a while ago, being able to provide some additional detail to give you some information. What do we have for container logs?
Sure. So logs are basically what you can get out of a container is the output of whatever the container is running, as long as you've configured that to output to standard output, right? So some containers, if you pull a professional image, right, or an image from a place that's designed to run this way, they'll take standard error and standard out of whatever application you're trying to run and put them just to standard out so that when you run a Podman logs, you'll see the output of the application. Now, if you were at a shell, this would be just like running a service interactively, right? Except this inside of the container puts it in the background. So it's not, monopolizing your interface. So if you want to bring the terminal back up, we will show you how this works. So I've devised a very simple container here. I'm going to show you how it's set up. We called it logger just because it logs to the output here. I made a simple file here, shell script that just echoes the host name, or not the host name, but echoes the time. Wow. Oh yeah, it must have. Did it really? Did I mess up my thing here? Hold on. Why does it say that? Okay. All right, so you're going to have to take my word for it. This was supposed to output the the output of the actual date and time, but in the scripts that I used to create this, I messed up, and it actually put in the date and time that that was on the host when I ran it. So we're just going to run it anyway. But it's basically a script that just echoes the same thing to the output, right? All right, so I forgot to show you the container file as well. Container file is simple. It just pulls a UBI image and it runs my script, right? So I've already built this container. We're just going to run it here. All right, so now we have it running in the background, and we're just going to look at the logs. Right, so like I said, this was supposed to be updating the time every time it ran, but you can see instance after instance, every 5 seconds, it's putting out the same thing to the screen, right? So this is exactly, this is the logs. If this were a service running in the foreground in my container, like Apache, for example, in fact, if we do Podman logs on my Apache container, it's going to show me just the basic output that it's getting from Apache. You could redirect your Apache access and error logs to standard out, which would then also get you the actual access logs and whatnot from Apache. Instead, this is just giving me the usual output that you would see in the Apache service log because of the running application. So I also wanted to show you, you can get logs. So right now we've been getting logs on a container, one specific container. We can also get logs on an entire pod. If you remember, we talked about pods in another episode. So first we're going to stop. In fact, let's stop all of our running containers at the moment. And you're going to see my logger one, because it's not very well behaved, has to time out and get killed. Because, like I said, very simple script. Now we're going to run new containers within a pod. Let me get my comment or my commands here. Okay, so we're going to make a pod. No, that was the wrong one. Sorry. We're going to make a pod. This is what happens when you don't put your commands in the file properly. I had to rush today's. Going to get rid of that one again, and then we're going to make the pod that I talked about. As soon as it stops. We call it loggers because we're going to put a bunch of loggers inside of it. And then we are going to, these I have in my thing here. We're just going to make 3 separate instances of the logging container. We're going to call them logger 1, 2, and 3. Okay, now if we do a podman ps, we're going to see 3 instances of logger running. Do a pod ps, we're going to see we have a pod running. I didn't put them in the pod. Man, I'm just messing up left and right here, aren't I?
And this is what happens when you put together the episode guide like 10 minutes before the episode.
Yeah, no, the real embarrassing thing is I did this a few days ago. The problem is when I was creating the guide, I was like troubleshooting stuff within how I wanted it to run and how it was really supposed to run. Okay, now we're going to run them again. Didn't get rid of my pod, did it? No, it didn't. Okay, we're going to run them again. This time, putting them in the right pod. And one off script, guys. Sorry. Now, you see the 3 running. And if we do a pod PS, we're going to see it says number of containers running within the pod is 4. Now, we can still do a podman logs on an individual container. Logger 1, right? Or logger 2, or logger 3. But if I want to get the logs from everything in the pod, so say in the pod I had like, I don't know, Apache and MariaDB running. And I want to see the logs from everything because I'm just like, I'm not sure where the problem is. And I want to, I want to see the logs from everything. If I do a Podman logs on the name of the pod, it'll show me the logs from every container within the pod. Pod logs. Right, and if my script was written properly, it would have been showing the host name here in this column. So that would have made it a little bit easier to differentiate. But you can see that the pod or the container IDs in here are all separate. So you can match those up with the container IDs in a Podman PS. And you can see, like the C260 is this, that's logger number 3, right? So we can get logs from everything at once.
And that's actually really handy because you can look at like a time-based. Well, I guess this is all in one. Each one is separated and run on its own. But if you had timestamps in there, you could also look across them using the timestamp to figure out what was happening in each one at that time.
Right. So imagine that this is realistic log data that has date and timestamps and service identification information. If you did a Podman logs on the entire pod, you'd end up with all of the logs, and you can then parse through them to see what's doing what. Right. So that's a handy thing.
And just like we saw on the critical path, we could connect to the bash shell of any one of these individual containers running in the pod.
Yep.
So we could also run like diagnostic things.
Yeah, we're going to poke at that a little bit more in a bit. I had one other thing I wanted to show you guys first if we're done talking about the Podman pod logs. We're going to stop all these again, and we're going to bring Apache back. There's another cool, this is going to take 30 seconds, I think now, or maybe, no, I guess it's just 10 because of the 3 pods. But there's a cool command within Podman where you can get the status of your running container. Not just is it running or not, but you can get like the whole state, and it's called Podman inspect. We're going to bring the HTTPD container back. You can see it's now running here. If we do a Podman inspect on HTTPD, then it gives us all of this JSON output, right? Now, obviously, this is useful if you want to parse through all of this to see, what is where, what's the format look like, what are my network settings? It gives you all this information, like what's my IP address. But there's also a way that you can format the output. There's actually 2 ways you can do it. There's a -F option to Podman inspect, where you can then give it a sort of like a query. That'll give you that particular piece, right? So let me see if I can get the syntax here right. Put it in quotes. We do 2 curly braces, and then what was it? Network settings I was looking at before. What was it? IP address. Got that right. Otherwise, it's going to be a really, IP address. The P is capitalized. I think this is case sensitive, though I haven't tried otherwise. And this gives us the IP address of the container, right? You can also pass this into, there's a command line utility that will parse JSON called JQ. And that's another way you can get this done. So if you prefer JQ, if you're familiar with JQ, you can also just put it through that, right? If you're already familiar with that tool. But the other thing that I wanted to show you is we can grab out of here. Well, actually, first, are there any questions about that? Any comments? Like, this is a really good way to just see what your currently running pod is doing, right? If you wanted to, say, recreate this pod, for example, and you weren't the person that ran it, you don't have a definition as to what the pod looked like, you could discern from, the Podman inspect what was probably run when the thing was executed to begin with. Another thing we can get is the process ID of the container, right? And I'm going to show you why that's important in just a second, because there's a really fun tool that I actually just recently learned about that lets you run things within the namespace of the process ID, right? And as we know, a container is just a process ID running on your host that's, containerized within a namespace, right? So let's get that process ID, and then there's a command here. So let's say you wanted to run a tool like, I don't know, netstat or SS within your container, or any tool that isn't installed within your container, within reason. There's two ways you could get that done. You could install the tool in the container and run it for troubleshooting purposes, and then reinstantiate the container to get rid of that tool or remove the extra tool when you're done. Or in the case of SS and a couple other tools, you can actually run these inspection tools against the namespace of the container with nsenter. So nsenter is namespace enter, right? As you might assume. -n tells it to also attach to the networking namespace of that particular process. -t, we give it the process ID, so 4870. This is my HTTPD container from earlier. And then we tell it what command we want to run. Now, this is running SS from my host, right, from the container host, inside of the namespace of the container. So remember that. In fact, I'll show you. We can do a Podman exec on this container later, and I'll show you that SS isn't even there. But we're going to give it some common options here, which tells it to basically, this is what you might run on any host to see what ports are listening, right? We hit enter, and sure enough, there we go. We see that HTTPD, right, is the thing that's running here, and it's listening on port 80. So if you were to stand up a container, you weren't sure what port the service inside of it was listening on, this is a great way to find that. Hold on. If we go into a bash shell, we'll see that SS is not even here, right? So we ran it from the host inside of the namespace of the container. I think that's a really cool tool.
That is a really cool tool. Are there other things you would want to enter the namespace to look at?
So I've tried things like, say you wanted to edit a file with Vim or something, and I haven't been able to work out the exact incarnation or incantation that I need to put into nsenter to get that done, because the file system is not also mapped. And if I map the file system, then the applications that are on the container are the applications that are available to my shell. So there must be some way to get that done, but I haven't been able to figure it out. But, you know, say you wanted to run nmap, say you wanted to run, I don't know, anything within that container that isn't already there, within reason.
No, it's really cool because the alternative is you end up building a derivative container with a bunch of
Right.
tooling built into it that you then have to throw away or replace or comment out in your container file. You're ready to move to a production that has less software in it.
Right, right. So theoretically, depending how the container's built, if there's a package manager in there, you could just shell into it using Podman exec, install the tools you want, do your troubleshooting, and then either remove them when you're done or rebuild the container, right? So that's another way to get it done. But I think this is a lot cleaner, right? Can I do an IP adder show? You probably could. Let's try it. Off script again. Just do IPA. There you go. So let's see. Is that? Yeah, that's the IP of the container. So yeah, there you go. There you go, Shantanu. All right. So I had one more, and I think we have time for it. So this one, again, we've talked about pods. I showed you how to get Podman logs for a whole pod. There's another interesting thing that I like to do if I have a complex deployment where there's several pods that talk to each other over TCP ports inside, or not pods, several containers inside of a pod that talk to each other over TCP ports within the pod. You may not have those exposed externally, right? They may just be exposed to other containers in the pod. So what if you suspect one container within the pod cannot reach another container within the pod, and you want to be able to troubleshoot just at a network level? Are they able to talk to each other? Well, that's difficult to do unless you get into one of the containers in the pod, right? But as we just talked about, the containers in the pod may not have the troubleshooting tools on them that you want. Or maybe you don't want to change the state of the containers that are running because you're trying to troubleshoot the problem and you're trying to find a root cause before you modify anything, before you touch pretty much anything. So in that circumstance, we're going to stop things again here. In that circumstance, it's useful to be able to get a shell within the network of the pod, right? And you can do that by simply attaching a new container to the pod. So we're going to do another pod here. This time I actually put the command in here. So this might be a better planned demo. So podman pod create, we're going to call it httpd test. I'm going to use the same old httpd container, and this is going to be a very contrived example. You're going to have to bear with me. Just imagine that this was a more complex deployment, and that's why we're doing this. So we're going to build a new httpd container. And you're going to notice the pod, I didn't expose 80 or 8080 or anything. I didn't expose any ports on the pod. And I'm not exposing any ports at the container level. We're going to run it. We're going to call it httpd pod. We're going to put it inside of httpd test pod. We're going to map that same volume in that got me the index file. Now, imagine that this was like a database within the pod, right? And you wouldn't normally want to be able to reach it from outside of the pod. So if I make a new container here, hang on. We're going to make a new container using UBI. We're not going to have it do anything special. It's just pulling plain old UBI. Now, you might have maybe you build yourself a container that's full of just all of your troubleshooting tools, and you put that inside of your registry, right? We're going to use UBI because it serves the example here, but maybe this is like a tool that you put Nmap on and, other network troubleshooting tools, ping and NS lookups and, all kinds of stuff that you'd normally use for troubleshooting that you may not want to normally include in your production system, right? Now you can see we're going to put it inside of the httpd test pod. I use the --rm, which basically means once the container exits, it also deletes it, right? We're going to do it interactively, and it's going to just pull UBI9, right? So here we are. Now from here, remember, we can't reach Apache from outside of the pod, but from within the pod, we can. What do I call it? httpd-pod, right? And as we saw before in my troubleshooting, it should be listening on port 80. So if we just do a curl, now the networking within Podman also runs its own little DNS server. So you can call containers within a pod by their names, right? So from this pod, I should have DNS entries that say httpd pod is this other pod that's within the same container, right? Or within the same pod.
Nate,
and there's
DNS.
What's that?
It can't be DNS.
It can't be DNS. No, because DNS is taken care of for us. Curl-v to ensure retval. Oh, return value? I can do that if you want. -v. There you go. So the other neat thing, you notice it says it's connecting to localhost. Now that's because within the pod, hosts can see each other over localhost. I don't know how that magic works, but it works. So if you were to reference localhost, like if you're on your web container, you're trying to connect to your database, you can just say localhost on port 3306. It'll connect to the database pod or the database container over 3306, which is kind of neat. Some more networking magic that happens for you. All right, so we're right at time. How did I do that?
Happy.
All right, how many questions did I miss? Were there any questions in there we didn't catch?
There were not. It was relatively quiet today.
How could there not be questions? There was so much to talk about.
Oh, wait, we just got a late one in.
Are we able to find unused containers running on a host? Yes. So I stopped all my containers just before I did this. So there are containers that are stopped, right, that are not running. So those are effectively unused containers. Eric, if you can bring the terminal back up to there we go. So if we do a podman, yes, you'll see only the running containers. So there's one for the pod and there's one for HTTPD local. If we do a podman ps-a, it'll show us all of the containers, right? And that'll show you, of course, all the loggers that we stopped, the HTTPD one that we stopped, right? And I believe, yeah, it tells you here status exited so many minutes ago. Another thing that's useful is every time you build or pull a container or an image, it gets stored on your system, right? And those images, of course, are required to run containers. But if I say remove the container for all of those loggers, right? The image I probably don't I don't want to keep around. Maybe I'm never going to run this thing again. Maybe it was a troubleshooting container. Maybe it's a service that's been replaced by something else. If I do a podman prune, what that'll do is it'll go through and any images that are not assigned to containers that are defined, it'll delete those images. So that's another useful thing to keep in mind.
That could be super dangerous. That could be like you just have stuff in your image repository that you use sometimes, and now they're gone.
Yeah, I think it's images prune, not just, yeah, there we go. So, and it tells you what it's going to prune, or it'll tell you what it prunes, right? I forget if it comes back and asks you, are you sure you want to do this? But yes, if they're, I mean, ideally, these are images that are somewhere in a repository that you can just pull down again, right? So these are, yes, as Scott mentions, these are things you're going to want to be sure of before you remove an image, because if it's something you built locally and then you just removed it, right, and you need to run it again, you may have to rebuild that container. But if they're on remote repositories, it's not a big deal. It should just pull them down again. Troubleshoot containers from rootless users. Yeah, I've done all this stuff as root, but you should be able to troubleshoot any containers that are running as your user. Right. So, or I suppose as root, you could do it for other users, but you'd have to basically use it through sudo or su to get to Podman as that user. I don't know if there's a cleaner way to get that done.
Oh, I think it's more if you're running the container rootlessly as a specific user, you can then use these same commands and tools to connect to your running containers as that user. But
Yes,
just like connect to other people's running containers.
The only caveat is nsenter. Nsenter is a root command. You have to use that through sudo. So you could still get the process ID and then through sudo use nsenter, because that's not going to care what Podman thinks about who you are. It's just going to literally enter the namespace of the container. But all the other stuff I showed you today, if it's your container, you can run it as you, and you'll be able to do all of the same troubleshooting.
All right, I think that runs us off the end. So Nate, great job today. I learned a lot about troubleshooting containers.
Glad to hear it.
I
Sorry
like,
for the derail at the beginning.
it happens. I like connecting with Bash and like being able to poke around while this is known. So that was really cool to see. Any final words before I sign us off?
I just want to say that nsenter thing I learned because I'm taking a Red Hat training course on Podman containers, and I know quite a bit about Podman, and I've learned a few things from this like almost introductory level Podman course. So if you guys are curious about Podman or even OpenShift, the DO 180 series or do 180, 280, 380, whatever are the courses you're looking for. So 188 is the one I was taking.
Yep, and I threw it in a chat as well. So thanks everybody for joining us today. We will not be having an Into the Terminal next week because we have a Red Hat holiday. So all of us Red Hatters will be off doing other things. But we'll be back. And that means that we have a whole 2 weeks to figure out what it is we're going to be talking about in 2 weeks.
Plenty of time.
Yeah, possibly wrong. If you missed it, yesterday, RHEL Presents was talking with Randy Russell and Henry Main from the Red Hat certification team about Red Hat certification exams, like the Red Hat Certified System Administrator and the Red Hat Certified Engineer. And we'll be having a RHEL Presents in 2 weeks, but that is also a TBD topic. And then don't forget that Eric and John Spinks have been running a program on using Red Hat Insights and all the services and stuff that go along with it. So the modernizing management mini-series that they're doing next week is going to be on advisor, drift, and policies, which is compliance policies. So don't forget that. Oh, and I see that Eric just threw in the RHEL presents in 2 weeks is the value of Linux. So that's
There you go.
2 weeks Wednesday. Thank you, everyone. Don't forget to mash like and subscribe, and we will see you at another Into the Terminal.
Yeah, have a great one.